there are administrators there, vice-chancellors, deputy vice-chancellors, dean, professors, colleagues, and honoured guests. It's a real pleasure for me to stand here before you today. I'm extremely grateful to the university for giving me the opportunity to present this lecture. Before I go any further, I'm going to get rid of my very dry mouth because I've never been so frightened in my life. I'm going to attempt to leave my hat on. If it falls off though, don't be surprised because it's too small. I haven't made a great big list of all the people who've helped me in my life. If I did that, it would include nearly everybody sitting in this room and a few thousand others. I will endeavour, however, to give due recognition as I take you through a journey. Some lectures start off with, these are the objectives, the aims, this is what I'm going to tell you, and then proceed to do just that. I'm going to try and take you through an exploratory journey of technologies, interesting facts and figures, and my own journey through that change in history that's occurred over the last 3 or 4 decades. The world in which we live now is so different from the world I was born into. And I dare say many of my colleagues in this audience could say the same thing. This is a map of the world. It's not a map most of you will be familiar with, because Africa is bigger on this map than America. All of the maps that you normally see have those old colonial countries like Great Britain very big, and Europe very big, and America very big. This is called Peter's projection. It is a map of the world in relation to the scale of the countries. So this is a more true representation. That's an awkward saying, isn't it? Are there such things as truths? We'll discuss another day. But you see how big Africa is. I'm going to present some data like this, because this is the number of working physicians around the world, and you can see that when you plot them onto this map, it really does show you quite clearly that the number of physicians working in Africa is lower than anywhere else in the world. And you'll see how important this faculty in particular of health sciences is to this part of the world, and particularly the Eastern Cape. I'd also like to thank my colleagues here for welcoming me into the faculty. It has been a pleasure working here, and I hope it will be a pleasure for the next couple of years. Their work has been like mine. Most of the work that they do in academic terms is done on top of a workload which is long, hard, and takes a lot of effort. So I am more than surprised when I see the amazing academic efforts that so many of you undertake. And I'm really, really grateful for being allowed to help in some of those achievements. What is informatics? There are about 300 definitions. I could bore you to tears with definitions of informatics and standards. You'd be glad that out of my printed lecture I've left all the standards work. Standards are things that you need to be able to do very complex computations. You need to have a very strange mind to write standards, and an even stranger mind to read them out aloud to an audience. They do not figure in this lecture. Neither does the open source work that I've been involved with, because it would take too long to explain some of the concepts in it. So what I want to do is just take you through this journey, as I say. Informatics has been described by many, but the one I like, and I think Professor Longo-Mabenzi would enjoy the most, is it is the formation of the mind. It comes from the French. It is about how we say, as researchers, it forms the humility of research. However, I'm going to use my definition, and you'll see throughout this lecture that I actually quote myself a lot. Nobody else does, so I have to do this. It's a sequence of symbols that can be interpreted as a message. Traffic lights are a sequence of symbols which can be interpreted as a message. All of you know in certain parts of this country those messages aren't actually acted upon. Think about it. Or you can think of information as data that has been processed and is understood by the recipient. And that, for me, is probably the most important thing, because as a teacher, you can stand in front of a group of people and impart the most amazing things, but if none of the audience understand them, then you're not really giving them any information at all. This, at one point in my life, became one of the most important concepts I ever came across. All of these stages require a process. To go from data requires a process for it to be information. For information to be knowledge, it needs to be processed. And for information to mean anything as far as wisdom, it has to be processed. And it is those processes, I would argue, that you base education, particularly postgraduate education. I thought I'd share this one because I've seen in my life many organisations that are extremely efficient at doing things that they don't need to do. And I'm sure you can think of examples of organisations like that. Health informatics is not the same as informatics. Health informatics, this is a definition from a colleague of mine, Dennis Protty, who I was very glad to work with for many years. And he comes from Vancouver. And he says the study of nature and the principles of information and its applications within all aspects of healthcare delivery and promotion. I want to go back in time. Somebody said I should start talking about 1947 when I was born, or 1951 when I went to a certain school. But I'd like to go back to 1855. And I want to talk about three different people. The three people that most of you who are in healthcare will know at least one of them, but possibly not from the perspective that I'm going to talk about. So, the first is John Snow, who had a publication, and he talked about the mode of communication of cholera. In 1855, there was no thought whatsoever of diseases being carried by microorganisms. They were the humours. There were four humours. One of them was air. So you open the windows to let the bad odours and the bad humours out. And what this man did was he did a plot of data, and he noticed that there were various places in Broad Street in London, and this is the plot he actually used. So they're all deaths. He marked on this map every mortality. And he noticed that the higher concentration was around a water pump. And he did an ingenious thing, because nobody had thought that cholera had come from water. He actually took the handle off the pump so nobody could use the pump. And the mortality rate stopped going up. And people recovered. And it was the first time that people had actually put together the thought that you could have waterborne disease. He worked with a man called John Gunt, who published tables of diseases. London wanted to know why people were dying, and they wanted to see if there were other diseases that they could stop. And in London there was a thing called the Bill of Deaths, and it was actually a list of all those people who had died and why. There were 12 causes of death. It would make your jobs a lot easier if that's all there was nowadays. That was increased to 81. And in 1900, the first international conference on the international classification of the causes of death occurred. 26 countries took part in that. In 1948, the World Health Organization took over the development of these health stats. And ICDs have now grown to over 60,000 causes of disease, so morbidity and mortality. A lot of people I talk to who have been in computers actually think the ICD codes were invented so they could run computer programs, because this coding system has been the most used coding system around the world for coding diseases in the electronic patient record systems. This is what it looks like. You've never seen. This is the large overview. There is a massive textbook that goes along this. Here's a lady you all know. Any offers of recognition? Most famous nurse? This is a picture that appeared on the front page of the Illustrated London News, again in 1855. Why was it so important? Well, in 1852, there had been a cable laid between Great Britain and that island off it called Europe. And it allowed the transmission of information by telegraph. So for the first time ever, the Crimean War was reported on a daily basis. And unfortunately, friends, learning of people's death is not really a nice thing to read every day, especially when there are thousands dying. So the editor of the Illustrated London News asked could his team find something interesting to say about the Crimean War. And the reporter sent a story about a lady who had gone out and who had a lamp and walked around in this hospital trying to help. So somebody painted this picture from their own mind, because this looks nothing like the hospital in which she was working. And it was put on the front pages of all the newspapers, and the lady of the lamp was born. The lamp she carried, in fact, looked like B, which was a paper lantern, as opposed to one that had a lantern come out of it when you rubbed it. This is a map of the Crimea. Crimea is actually the Ukraine, modern Ukraine, and that's up at the top. I think I can use a cursor. Yes, there. So that's Ukraine. Miss Nightingale actually lived at the other side of the Black Sea, some 400 miles away, for 10 days by boat. So she wasn't actually in the thick of all this big fight that was going on. In fact, her main occupation while she was there, and for the 5 years after she came back, was to collect stats. She invented the polar diagram. She spent 5 years looking at the causes of deaths, and she showed that more people died in that hospital from the killer than they did from the bullets. She's famous for lots of things. This is actually a photocopy of one of her journals. And this is a hand-drawn diagram, a polar diagram. You call it a pie chart nowadays. She actually invented this as a presentation method. All the stats have been checked by people with modern computers, and you can't find any errors. She was actually the person who tried to take the stats that earlier we heard about and get hospitals to accept that they should have a method of collecting data. She's written quite a few papers on uniform plans of hospital statistics, and it was in later years that they were actually adopted and became part of the normal stats that hospitals collected throughout the United Kingdom, Europe, and then out to places like South Africa. She was honoured for her work in statistics in 1858 when she was elected as a Fellow of the Royal Statistical Society, and in 1874 as an honorary member of the American Statistical Association. And yet people call her a nurse and think of her as a nurse. Helen and I have written a paper, which you can see there, acclaiming her to be the first health informatician in the world. So in that year, there were lots of people collecting data. 1855 was really the beginning of the science of informatics, of data, and data being used to show that people were dying from causes other than what the general population at the time believed. It was the beginning, really, of epidemiology as a science, and the beginning of the scientific collection of data in a methodological way which resulted in the production of standardized data collection that could do comparisons on large global data streams. This is a collection of my computers. In 1980, I went to do a tutor's course and spent most of my time learning to program computers. I became fascinated by the whole thing. I set up a software library. My eldest son, Adam, was a very bright young man who had an amazing interest and capacity for computing. So at the age of 12, he was debugging programs and doing all sorts. He does this for a living now. And he's going to sit there and tell me all the things that I've said wrong in this lecture, from a technical point of view. But he had an unusual time as a young man, because this set of computers and about 10 others were all in our cupboard at home, because we had to have all these different computers for one program. Because there was no standardization, you had to have different variants of the program. This was a change in the UK and in parts of Europe and America that you mightn't have seen in the Eastern Cape. But I just want to take you through some of the things that we had. This is my first computer in 1980. It's an operating system that you only got to understand if you were a geek. That is somebody who had a strange mind and spent hours and hours trying to make a little spaceship go up the screen for no particular purpose other than make a little spaceship go up the screen. You had to write in, there was no graphic interfaces. This is FidoNet. We had email. The internet actually started in the 80s. In 1987 we set up, myself and David McHenry, an email system, and it took 24 hours to send an email to Australia because it went from one computer to another, 4 or 5 of them across England, then across to Holland, 6 or 7 across Europe, and down through to Australia, and then back up through America. America was always 24 hours behind everybody else. So no change. This is part of a bulletin service, and emails actually happened long before the World Wide Web and what people call the internet now occurred. FidoNet had, in the early days, very few users, or nodes as they were called, and it grew over a decade to 20,000 of these local things that you could send a message to somebody around the world on, which changed some things very dramatically. Queen Elizabeth actually sent an email in 1982, I think. And she was the first monarch ever to send an email. But she sent it on the Royal Signal's secret army installation to somebody in another secret installation, so nobody knows what the message actually said. The World Wide Web. This is a quote from a journalist in the Times magazine who said that Tim Berners-Lee is, I'm afraid, an Englishman and also a member of the British Computer Society, and like me, a fellow of the British Computer Society. And what this journalist said was, he wove the World Wide Web and created a mass media for the 21st century. The World Wide Web is Berners-Lee's alone. He designed it, he loosened it on the world, and he, more than anyone else, has fought to keep it open, non-proprietary and free. Now that's the most amazing thing when you think about it. The whole of the internet is free to use from anybody. You're allowed to put up servers, you're allowed to do all sorts of things. He was, and still is, an academic who believes in free access to knowledge and free transfer of knowledge. He eventually got knighted by the Queen, so he's now Sir Time, spelling mistake, Berners-Lee. He invented the idea of system resources, the URL, Uniform Resource Identifier, the publishing language, the markup language, HTML, and the hypertext transfer protocols. These 3 things made it possible to have a graphic interface for information, for messaging, for all the things that you now know that the internet does. And anything that's on your smartphone is also based on the same system. This really boring slide, which you can't read because it was never intended to be read at a distance. The esteemed colleagues at the front can see it, which is the more important thing. This is the world's first web page. This is the very first time that people saw the World Wide World, and the idea of hypertext links, so you could just click on something and move to another place. As a researcher, Tim Berners-Lee worked for CERN. I'll come back to CERN in a minute. But the very first time it was presented at a conference, the scientific committee said it wasn't worthy of paper presentation, and he presented it as a poster. And this is actually a photograph of that poster session. You know, this announcement that it was going to change the world so amazingly wasn't thought to be very much in the very beginning. For the other nerds in the audience, this is actually the algorithm for Tim Berners-Lee's life. I'm going to skip that. This is the first server ever for the World Wide Web. It was set up in CERN. CERN is the linear accelerator which goes between France and Switzerland underground. And he was employed as a programmer to help with the accelerator. And he told his boss that he'd changed all the way in which CERN could communicate with each other. And they had a meeting, and they decided that this work was so profound and would make such a difference that they were going to give it free to the world. So in 1994, CERN announced that the World Wide Web, technologies, information, access, everything would be free to use by anybody in the world. It's hard to believe that this is the growth of those sites. You see, up until, let me see if I can find it, yeah, there we go. Up until it was given away free, which was here, nothing really happened. And, sorry, it was 3 years later that it started to grow. It was academic departments who had World Wide Web access. It was places like the UK academies who were interested in developing this technology. And suddenly commercial people started realising what you could do with the technologies. And you notice this massive leap then in 2000. So 6 years on, there's been lots of academic work done on it. It was very much part of developing education, but suddenly the whole of the banking system switched over to, there was online shopping, online banking came in, airlines let you book your flights online. And it grew, and as you can see, up until 2008, it got up to 160 million websites were up and running. Now let's put this in perspective of Africa for a minute. We're back to Peter's projection. That's the number of computers that were about connected to the World Wide Web in 2002. It's rather slim in Africa. Massive in America, massive in the UK, Europe, massive in Russia, but not so big in some of the South Americas. But there was one computer for every 10 people on the planet. Here we go again. And this is the internet users in the same year. You might think that I'm saying South Africa and Africa was left behind completely, but with all stats, you know, you've got a distribution where there are some people who are really profound at these things. And there's two South Africans I need to talk about very briefly. This is the scientist who developed PayPal, the online payment system. He sold it for enough money to start up a company to build spaceships. And that's the spaceship he designed and built. Why is it important? Well, this is last month. This photograph is the International Space Station, and that's the spaceship designed by a South African that landed. He had all the money because he was an informatics person in the first place and did all the early adoption. There's another South African that has done amazingly big things, and that's Mark Shuttleworth, who was born in the Free State, and his dad was a surgeon in the Free State. He invented all the encryption technologies and security technologies and sold his company for billions, enough to transport himself on the Russian spacecraft to the International Space Station. He paid $50 million for the pleasure of being the first South African in space. He's now turned his attention to Ubuntu, which is an open source operating system which is now rivaling Microsoft as the way forward. So, I don't know whether you can read that at the back. It says, nurse, get on the internet, go to surgery.com, scroll down and click on the icon, are you totally lost? This is an estimate of the number of people it takes to look after one patient in a hospital. These are the number of different disciplines who interact directly with the patient. So it doesn't include all the people who never see a patient. These may seem random bits of information, but I'll come back to them and try to bring them together. In the UK, general practitioners started using computers for clinical and run the whole of their clinics on computers that they bought out of their own pockets, not the government supplied. And you can see by 1993 that the majority of GPs in England were running computer systems. That was the year before the World Wide Web was given to the world, and well before computers became popular. Why? Because they found that it saved them lives by reducing errors with prescriptions and things like that. This is a copy of the page from Hazard, which is the House of Commons, the UK Parliament's daily report. And Baroness Cumberledge, who was the Under Secretary of State, was delivering a speech about computers which suddenly become available. All these doctors were using computers in general practice. And she said, you know, people are becoming slaves to computers, and we can't have nurses to become slaves to data-hungry data collections. We may talk about that later as well here. But it's fair to say that in many NHS computers, they were used solely for stats purposes. And I see exactly the same in this country. Computers are used to collect data to give to the government rather than with clinical things on. But in response to this, the regional nursing officer for Yorkshire said that in Yorkshire, which is an amazingly nice place, over 1,000 copies of the learning programme using information to manage the nursing resource had been in use. This was an amazing thing. 1,000 copies of a book. Textbooks in England, if they sell well, sell 5,000 at the most for postgraduate, undergraduate and school teaching. There's a different thing. But this is taken from the BCS history book, which says probably the most well-known product to emerge was the Rainbow Pack, using information in managing the nursing research, of whom Graham Wright, Christine Greenhouse and Helen Jackson were instrumental in its development. This is one of the things I did in consultancy and at Manchester University. It was based on a problem-based learning and action learning sets. And what we had to do was find out why people had problems with finding the information in the first place, what sort of information they needed, how you used information. In other words, ignore what computers do. How do people actually gather information and what do they do with it? Now, this book sold 35,000 copies at £70 a time, which is, I think, about 800 grand. You can now buy, within the book, there are booklets. You can now go on Amazon and buy one of the little booklets for 30 pounds. So they're now selling at £200 a copy. So they've gone up 3 times the value when they were first sold. I think I probably hold the record for selling the most open learning texts in European history. It looked like this, it was very pretty, and that's why people bought it. One of the other big things we wanted to know as an emerging profession was, how do people in universities use information? And when the health service in the UK released their strategy for information management, I, with some other colleagues at Manchester, did a review on behalf of the government to find out whether the strategy actually could be implemented, whether the people could understand it. And those people in particular were those running medical schools and nursing schools. So we did a number of studies, and the first one, we did a set of recommendations, most of which were adopted by the government. And amongst those were the writing of 2 benefits realisation studies. I'm proud to say that the editor and main author of one of them was my wife, Helen. She also was involved in the follow-up study in 1990, and that report was submitted to the UK Council of Deans for Universities Nursing Departments. And the recommendations were there was how you put the recommendations and the requirements for nurses to understand the information, how they could be put into the nursing curriculum and the medical curriculums. If I can go back to 1991, I designed a workload system. Time management and workload management systems are quite complex stats. You do a time slicing method. So if you observe an activity and you observe that activity with sufficient frequency, you can build up a distribution of those frequencies. So this is pre-computer. This is called a time tech board, and it only recorded a code. So you had to have an operator who could remember 400 codes. And I designed the system that made it easier for them to understand it. And what it captured was, what was the healthcare worker doing? So, which healthcare worker, what they were doing to which patient. So there's a code for the healthcare worker, a code for the activity, and a code for the patient. We took a massive amount of data from these collections. We did 250 events over every 24 hours from one collection. and we did some very big hospitals in the UK. Methodology showed some quite interesting things, like nurses were spending 40% of their time in communications, usually with each other rather than with patients. And that doctors really were overworked, but they were doing things that they shouldn't have been doing. So we were commissioned eventually by the UK government to do a study on junior doctors and nurses, a research study for the Department of Health, which was later called the Greenhouse Report. And that basically changed the hours that doctors worked in the UK, the activities that they undertaken, the introduction of physicians' assistants, the introduction of nurse practitioners. So actually, skill mix profiling and moving activities from junior doctors to, and the changing of the doctors' hours and things like that. Around the same time, I also got asked to be part of the team that got a €1 million fund to develop a piece of teaching material. What is informatics? Lots of things divided into work sets, and basically 10 work sets. And I wrote the educational basis and looked after the authorship of this. This is a CD which is available in every language but English on the internet. I have all the English copies available in my office, so if anybody would like a copy of this, it's the most amazing set of tools for anybody who wants to know about information use or how a scanner works. So there's a lot of basic science in there. It was during these times that I became extremely interested in evaluation studies. So I did a lot of monitoring evaluation of the health service management unit. And I worked with Yossart's Victor Peel, and we sat in Copenhagen at a conference and went through what we saw as the major reasons why IT systems failed. Amongst the causes, there wasn't one that was to do with IT. All the failures were due to other reasons, like organisations not being ready for change, nobody having leadership, no training, no implementation plan, no fiscal policy, no adoption policy, etc., etc. And I see my colleague Rajiv is sat there nodding, because this is what he does for a living now, and it hasn't changed at all in the last 20 years. Our paper is now in the Harvard Classic Paper Series. I was convinced by Yossart's that the way you published academic papers wasn't the one who did the most work first. You always did things alphabetically. So it was always Yossart's first, me last. But there was something good about that, because arts is spelt with a double A. So if you go on the internet looking for one of our papers, we're the first things that come up. So, you know, we always head to the top of papers, so that's quite nice. This is the model that we developed, which at the time, I have to say, the International Medical Informatics Association said, that's got nothing to do with health informatics. There's no computing in it. And we said, well, no, this is what you really need to look at to make things successful. We ran the only master's course in the world that had these concepts in. And over the next 15 years, we were extremely pleased to see modules developed in every other university master's program on health informatics. and it's nice to get the recognition. All of the things I've talked about are what activities were there going on in health informatics and in my life in health informatics. But really, it wasn't recognised as a discipline. There was no professional status at that particular point in time. There were the beginning of master's programmes. And the words health informatics and medical informatics were used interchangeably. So my team and I sat down with the thought of, well, how do you define a discipline? How do you know where the boundaries of a discipline that's just starting come from? Because all the classic disciplines, you know the roots, you know where the start off. This was a quick search I did on Google Scholar for the terms health informatics, medical and bioinformatics. In April this year, when I was sitting down, I must have used my hands, I know, writing this paper. And you'll see that bioinformatics is 10 times the number of publications than the others. And this is predominantly about genomics. So we took a decision nearly half a decade ago that we would exclude them from our studies. I think it was probably the right decision. This is the team I'm talking about, the research team. They're all looking different ways because that's the way we thought most people behaved at that time. On the extreme right, your right, there's Dr. Peter Murray. Next to him was Dr. Helen Betts, as she was, sat there. And the rather large chap in the middle is my son. I had 4 weekends, long weekends, explaining to my colleagues what I wanted to do. And they said, well, if you try and explain that to the majority of practitioners, they'd fall asleep, walk out on you, or throw things at you. You have to have some sort of picture that you can give them when you're talking. And Helen used to breed coal ducks, which are miniature ducks. And she thought of the idea of ducks on a pond. We spent lots of weeks preparing this. Believe it or not, the picture on this side has words written on it, but when you photograph it, you can't see them. And we wanted to use a methodology. It's based on Bloom's technologies, taxonomies for the educationalists here. And we wanted to look at themes. And we wanted to look at those themes. And Helen said, well, you could call the themes ponds. And you could call the elements within those themes ducks. And then people would be able to get their head around it. We were talking about these sort of things. Now, I don't think, other than 3 other people in the audience, you would have a clue what any of these things were. But these are examples of activities in health informatics. So, and we showed them this slide, which shows you Bloom's technology along the top there. So going through knowledge, comprehension, application, analysis, synthesis to evaluation, where the different parts of IT on the left-hand side, and then some activity behaviours. We had these nice big blue duck ponds, and we invited a sample of the population of some of the world's experts. So we had people from the States, Europe, UK, South Africa. We had Sadiq Isaacs from South Africa came over, who sent his apologies for not being with you here today. And we got people to look at this and put their ideas, what the elements were within each of these themes. The reason you want it big like this is people can't see this on a computer screen. You can't get people thinking and brainstorming these sort of issues on a small screen. You've got to have lots of space. And we had a very big venue. And we had these people trapped there for 24 hours. We fed them and watered them, but they didn't leave. And then we captured these things. The reason for experimenting was we wanted to photograph them, and then we projected them, and we used an electronic voting system as whether people thought these things belonged or not. So we first asked people to brainstorm, and then for consensus. And you can see the sort of things people were talking about. Notice the method of first to second to third degree pair references. It doesn't mean anything to you, but believe me, to a health informatician it does. So we had a lot of these processes using Bloom's taxonomy, as you can see. And we produced an initial set. So this is a set of ideas that a group of experts from a small sample had. We thought that was nice, you know, it's a cognitive map. We have a starting place. But how do you find out how everybody who works in the discipline thinks? We thought all sorts of methodologies, and like all researchers, we went down lots of blind alleys doing things. But we came up with the concept of using keywords in published articles. So we collected every published paper electronically, even all the grey literature from every conference. So for teaching now I have a lovely database. And we use some technologies to look at those. And unfortunately the technologies 4 years ago weren't up to doing the job properly, accurately. They have different algorithms within them. The only indexing program we came across that could do the job was owned by CIA, and they wouldn't lend us it. So we collected instead from some online databases. So if you look at a normal reference from an online database, you get all the keywords listed. We used a reference manager tool to extract all of those citations into a spreadsheet. The spreadsheet, unfortunately, couldn't house all these sort of words because there was over 250,000 keywords. So we had to do some clever things with spreadsheets, and eventually we ended up with a count of all the words from each spreadsheet. We put that into a collation database and collated the things that we'd got in the mapping with them. And these are some of the keywords that we came up with. The ones that are in bold are ones that the experts said. Some of the words that you find in keywords are things like South Africa, and so country names and things like that. So there are words that don't mean anything in terms of the scientific information inside it often. So we had to look and see how we could take out of those 250,000 and get it down to a manageable size. We had a meeting in the British Computer Society, and I happened to be the treasurer of this august society, and I spent £750,000 every year on myself. Other people. So Peter and Helen and I invited lots of people to a lovely venue in London and give them lots of food and drink. And we sent them a virtual delegate pack, because by that time we'd got lots of information. And we've chopped down these, by taking and all the words that don't mean anything out of this list, we've got down to 10,000 words. We only wanted the words which uniquely describe health informatics. So in this workshop we reduced the 10,000 to 444. And then we sent them out, that's the project. This is the number of appearances. And we asked people to vote internationally. We sent the spreadsheet to lots and lots of health informaticians around the world and asked them to send them to their colleagues. And we got an amazing response. And they voted yes, no, or possible, and sent them back, and we collated the whole lot. And we came back to this voting in method. And we had another big meeting. We took those 444 and fitted them into the framework. And we ran workshops in, Peter will tell me in a minute, in various places in Europe, and got consensus. And we produced what is now called the EMEA knowledge base, which is the foundation of what is health informatics at a point in time 2 years ago when we finished doing that slice of time study. It is published on the EMEA websites. We'd be happy to be involved in taking it further, but after 6 years we think we've probably done enough for all this. How does that benefit Walter Sisulu? Well, this university now is the place where that sort of work is being looked upon to carry on. It's also a place where the Dean had a dream that information technology and health information would exist within the faculty. I was invited by Sadiq Isaacs to go and visit Cape Town. Helen and I went, and Dee and Sadiq took us all around Cape Town and introduced us to a lot of people. And one of those people was Len Heyman, sat in the front here. And her and a colleague conned me, that's the right word, conned me into running a workshop instead of having a holiday. So my wife wasn't pleased about this, giving up her holiday to do a workshop. So we stayed a couple of extra days in Cape Town and had an amazingly nice workshop on clinical information systems. The then director of the MRC asked me if I'd be willing to bring the master's programme here to Walter Sisulu University. And there was lots and lots of negotiations. And this is the very first meeting of the quality team. That's Sadiq sat down next to the deputy dean and the dean and my wife and two people out of the Department of Health. They both became students, and the young lady, 6 years later, is the Deputy DG of Land Reform, and she sent her apology for not being here today because the Minister sent her to Limpopo to sort things out. It's not the first time I've stood on the stage. In fact, this is the launch of the MSc programme. There are successful candidates from that programme sat in this audience today. Ask them. And you see Peter Murray yet again in the photograph. He was foolish enough to agree to come with me to Untata for a number of the modules. This is the group. This is the group visiting Florence Nightingale's I was going to say funeral place, memorial. This is me, Jimmy Chandia, and lots of other people, Casey, who sat up there, with Her Excellency, the High Commissioner for South Africa, at South Africa House in London, where we'd had tea. She was so blown by the fact that her cousin Menti, who sat back there, actually was working in Untata and on this course, and Dr. Pradden, who unfortunately is not very well, who was also there, her nephew worked with him, that she wanted to talk about Untata and the work at WSU. So she ordered the first secretary to cancel her evenings and fix a dinner for them. So we all went and had dinner with Her Excellency, and they contrived to have the immigration man, the guy in charge of immigration, sit between me and Helen and persuaded us that we should come and live in Untata. I told you he's a very persuasive man. This is the group from Untata talking to some of the top academics in the world in health informatics. This was at a conference that, again, me, Peter and Helen had organised as a special topic conference on open source at the BCS. They did get up to naughty things while visiting the palace. This is the police arresting them. We voted many times were to take the EMEA conference. Every 3 years there's a massive health informatics conference where every scientist in the health informatics field. And in, I think it was 2008, we voted for it to come to South Africa in 2010. And I'd like to say that Lynn Hanmer was the chair of that conference. She organised it with Brenda Fay, who was also sat in the audience, and it was an honour to be there, to see it in South Africa. Many of us had papers there, and you'll see Peter's, this is the General Assembly. These are all the top scientists in this field. The whole area of social networks has started to hit Africa. Not because of computers, but because of mobile phones. Africa has leapfrogged in technologies. When I first came to Untata, we used to wait for a day for the results of a Google search. I can now get 3G anywhere. We have smartphones. We recently interviewed 30 nurses. All of them had smartphones. Most of them used Twitter, Facebook, LinkedIn, etc. And a lot of other ones that I'd never heard of. Only one of them could use a computer. So there's this massive change. This is the world map of social networks. And you'll notice South Africa is up there with everybody else. It would be remiss of me not to tell you that we use social networks. I set up a voluntary registration program for health informaticians who wanted to be recognised as being a member of a profession. So we've now defined a discipline. What I'm I'm saying is I've now started to collect the names of scientists who want to be recognised as being in their profession and registered as health informaticians. This is the screenshot of that web page, and we've got 1,101 as of this morning people registered, voluntary, to start an international register for health informaticians. I would suggest, my friends, that this discipline is starting to come of age. It's 50 years old. It now knows what the boundaries of the discipline is. It now knows that it wants to have a governing body that rules it. It now has massive conferences around the world, which have moved to every 2 years rather than every 3. So I'd like to conclude. I tried to take you on the journey, my journey, but the journey of health informatics, I think, as well, from this perspective of the work that I've been involved with. My academic development in particular has been, alongside my wife Helen, I've worked with her closely. She used to be my boss because she was the dean in the faculty I worked in at the University of Winchester. Dr. Peter Murray, who I've mentioned a few times, Jean Roberts, Yossard Spickpeel, Dennis Protty, Professor Duncan Nicol, who was the boss of the English Health Service, who was a fellow with me at Manchester University, and actually gave me my reference for the Surrey University job, which said in the concluding sentence, if anybody in the UK can sort out your mess, it's Graham Wright. I think Sidit Isaacs I'm also indebted to in the South African Health Informatics Society. But I think more than anything I'm indebted to the Dean and his persistence, his ability to see into the future and to say, we need this to happen in Montana. And to you, sir, I'm extremely grateful. I landed back from the UK a couple of weeks ago, and the immigration officer said, a British passport in New York. Oh, you've got permanent residency, I see. I said, yeah. He said, welcome home, sir. Thank you very much.